Assalamualaikum and a very good day to Dr. Farida. Today, my friends and I are going to present our topic, which is a solar hot water system, a vital component of modern building services that is not just luxury, but it is a fundamental part of the water supply network that is essential for maintaining high standards of sanitation and cleaning in our living and working environment. As we move toward greener 2026 standards, the solar hot water system has become a primary solution, and by harnessing solar radiation to heat water, that we significantly reduce a building's reliance on traditional non-renewable electricity and gas. And this transition is a major step in decarbonizing our built environment. When we look at the hardware, we generally choose between two technologies based on the building's needs. First, we have a flat plate collectors. These are the workhorses of the industry that commonly installed in residential buildings due to their durability and cost effectiveness. Second, for project require high thermal output, we use evacuated tube collectors. These are designed for higher efficiency, that making them the preferred choice for commercial building or industrial sites where demand for hot water is much greater. And the successful implementation of this system is never a solo effort. It requires a disciplined collaboration between three key players, which is engineers, quantity surveyors, and contractors. And the advantages of solar hot water are undeniable, because it is a highly energy efficient and environmentally friendly solution that requires remarkable low maintenance compared to mechanical boilers. So by choosing solar, we are not just following a trend, but we are actively reducing utility costs and the carbon footprint of our project. Next is literature review. So this literature review highlights the global focus on sustainable development, which has driven the adoption of energy efficient technologies in the building sector. So many studies emphasize that the importance of reducing energy consumption and environmental impact through the use of renewable energy system. The literature identifies that solar hot water system as an effective solution because they utilize renewable solar energy to reduce reliance on fossil fuels and lower overall energy consumption. This technology is considered highly relevant in rapidly urbanizing regions, particularly in countries such as China, where the number of high-rise residential buildings continues to increase. According to SHU 2023, solar hot water system play an important role in improving energy efficiency in high-rise development. Based on the literature, solar energy offers several advantages. It is abundant and locally available, has low operating costs, and produces zero carbon emission during operation. So these benefits make solar hot water system environmentally sustainable and economically viable. The literature also highlights that the core component of the system is the solar collector. Flat plate collectors are commonly used due to their low cost and suitable for moderate climates. However, vacuum tube and heat pipe collectors are reported to have higher efficiency and better performance in colder climates. In terms of system operation, the literature identifies natural circulation system as simple but limited for high-rise buildings. Forced circulation systems are more flexible and widely recommended for multi-story buildings with high hot water demand. Overall, the literature concludes that the effective performance of solar hot water system depends on proper design, correct installation, and appropriate architectural integration. When implemented successfully, this system contributes to improved energy efficiency, reduce carbon emission and sustainable for urban development.
Next, I will present the methodology of our project. The purpose of this study is to understand how the system works and to identify its advantages using information from previous study. To achieve this, reference from previous study and existing reports were used to gather reliable information. This research mainly used a qualitative method. One key reference is an article titled Project of Building Solar Hot Water by Shu Yugang, which discuss the design, components, and benefits of solar hot water system, especially in reducing energy consumption in buildings. The qualitative approach was chosen because it provides detailed explanation and flexibility, allowing a deeper understanding of the system and its advantages.
Now I'm going to present the main component of a domestic solar hot water system. The system consists of solar collector, a storage tank, and a circulation system which work together to capture solar energy and supply hot water efficiently for household use. Firstly, the solar collectors is installed on the roof at an inclined angle to maximize exposure to solar radiation. Its main function is to absorb heat from the sun and transfer it to the working fluid within the system. Next, the storage tank stores the heated water and is well insulated to reduce heat loss. Hot water is drawn from the top of the tank while cool water enters from the bottom to maintain efficient circulation. The circulation system then allows water to flow between the collector and the storage tank. This can operate as an active system using a pump or as a passive system that relies on natural convection. Control and sensor unit which monitor the temperature of the water in both the collector and the storage tank. When the temperature difference reach the set level, the controller activates the circulation pump to ensure efficient heat transfer. In addition, a backup heater is provided to maintain hot water supply during periods of low solar radiation such as at night or on cloudy days. This ensures consistent performance and user comfort. Lastly, the piping and valve connect all system components and control the flow of water throughout the system. Heat-resistant pipe and safety devices such as temperature and pressure relief valve are used to ensure safe operation. For the indirect system, a heat exchanger is installed to transfer heat from the solar heated fluid to the domestic water without mixing the two. This improves efficiency while protecting water quality.
This slide describes the centralized hot water supply system commonly used in high-rise buildings. In this system, hot water is generated at a central location using heating equipment and distributed through insulated pipe networks to serve bathrooms, kitchens, and service areas. Due to building height, the system is divided into pressure zones to maintain stable water pressure and temperature across all floors. Safety and energy efficiency are ensured through the use of thermostatic mixing valves and pipe insulation. In the Malaysian construction industry, this system is widely applied in apartments, hotels, and hospitals, and is designed to comply with UBBL and JKR mechanical service guidelines. This slide summarizes the key characteristics, installation process, and cost consideration of a solar hot water system. In terms of system characteristics, solar hot water systems are designed to be durable with an expected lifespan approximately 15 years or more when properly installed and maintained. Efficient solar energy collection is achieved through absorber fins, copper tubes, and a glass cover, while high thermal conductivity allows effective heat transfer. The system also includes a well-insulated stainless steel storage tank to maintain water temperature. This slide explains the professional roles involved in implementing a solar hot water system. The quantity surveyor is responsible for cost planning, preparing list of quantities, evaluating tenders, and managing budget control, including life cycle cost considerations. The engineer plays a key role in designing the system, selecting suitable components, and ensuring compliance with UBBL, JKR, and engineering standards, as well as overseeing testing and commissioning. Meanwhile, the contractor is responsible for the installation of the system on site, ensuring quality workmanship, safety compliance, and proper system handover. Together, these professionals ensure that the solar water system is cost effective, technically reliable, and perform efficiently throughout its service life.
To conclude, solar hot water system represent an important and sustainable component of modern building services, especially for high-rise residential and commercial building with high hot water demand. This study has highlighted the fundamental principle, system components, and operational aspect of solar hot water system, showing how they function as an integrated part of the building water supply network. The analysis demonstrates that when properly designed, installed, and maintained, solar hot water system can significantly reduce energy consumption, operating costs, and reliance on non-renewable energy sources. Therefore, correct system integration and management are essential to ensure consistent performance, user safety, and long-term sustainable benefit.